Let's look at solving trigonometric equations where we're using factoring and identities. Example, solve 2 times cosine squared theta minus cosine theta minus 1 equals 0. And we have this nice constraint here, just 0 to 2 pi. Now, I want to take this opportunity to, if you're given an equation that looks like this, but let's say that middle term here, so I'll just rewrite it over here. If you start with something like this, where this is the same equation, I'll read it out. 2 times cosine squared of theta minus cosine of negative theta minus 1 equals 0. This is going to turn into the same equation, but something like this is just asking you to recognize that cosine is an even function. And so because it's an even function, I know that cosine of negative theta is the same as cosine of theta. And so this just becomes minus cosine of theta minus 1 equals 0. So why do I bring this up? Well, I don't think it's worth doing a whole other equation in terms of solving, but you might see things like that where inside is like one of them is a negative theta or something like that. And then you just use your even odd properties of our trig functions to make them all look like theta. So if you see something like that, that's how you handle it. Okay, back to our original one. So what do we do now that we have this weird 2 cosine squared theta minus cosine theta minus 1 equals 0? So the good thing we have going for us is that these are all in terms of theta and a cosine. So we have plain thetas, that's what we want, and cosine and cosine. Now the thing that's maybe working against us is we have cosine squared theta in one term and cosine theta in another term. But it's kind of giving me the vibes of some type of quadratic term. So maybe like 2x squared minus x minus 1 equals 0. And I go, wait a minute, for something like that, I'd probably figure out how to factor it because that's what I would need to solve it. So let's see if I can use factoring over here. So if I wanted to do that, what would that look like? Well, I could use it like, kind of set up my spots. I know that these last spots here, so like this spot and this spot, those were binomial times a binomial, right? So the second spot times the second spot has to equal -1. So I'm just going to put 1 as 1 and 1 as -1 because it kind of has to work that way. Now I want the middle term to work out to be negative cosine theta. So I'm going to write the first and the first two terms have to multiply to be 2 cosine squared theta. So try cosine theta in this first spot. Okay, that would give me 2 cosine theta times -1 would be negative cosine theta. And then if I just had cosine theta in the front here, so this was just adding +1, let's see if that would work out. So you can always check yourself, right? I mean, sometimes I kind of think of this kind of thing on the side as kind of my own space to just kind of check things. So I could say, let's check. I would get 2 cosine theta times -1 is negative cosine theta. So that was just my starting with here and here. Now if I do 2 cosine theta times cosine theta, I get 2 cosine squared theta. And multiplying, say, my inner terms, I get cosine theta times 1, it's just cosine theta. And if I get just 1 times -1, I get -1. So would this give me my original equation? Let's see. I have the 2 cosine squared theta, great, and then -2 cosine theta, and then plus a cosine theta would give me negative cosine theta, and then -1. Okay, so I've factored this correctly, which is good. And so now what I'm going to do is use that zero product principle to set each factor equal to 0. So I'm going to have 2 cosine of theta plus 1 equals 0, and then write that word or cosine theta minus 1 could equal 0, right? Either one of those would result in a true statement. So let's solve this first one. I get 2 cosine theta equals -1. Again, I'm just trying to isolate cosine theta to begin with. And then from there, I want to know when is this true. Cosine of theta is equal to -1/2 at 2 pi over 3 and 4 pi over 3. Okay. And then cosine theta minus 1 is cosine theta equals 1. Where is that true? That is true. Right out here. Okay. At 0 radians. Okay. And so what is so I get theta equals 2 pi over 3. Theta is 4 pi over 3. And then over here I get theta equals 0. So now I want to kind of collect everybody. These are all between 0 and 2 pi, so I'm good to go there. And I know if I found coterminal angles, it would be outside that interval, so I don't need to look for more. So what are my answers? 0, 2 pi over 3, and 4 pi over 3. Next example, solve. Sine squared of theta minus sine theta equals cosine squared theta. And again, solve in that interval 0 to 2 pi. Well, things I have going for me. Theta is the input for each term. Theta, theta, theta. Things I have working against me. I have a cosine and a sine. Not always great. So what I'm going to do is rewrite cosine squared theta as 1 minus sine squared theta. So as a reminder, I have the identity cosine squared theta plus sine squared theta equals 1. And because I have 2 sine terms and 1 cosine term, I'm going to try to get rid of that one. So I'm going to solve this. And cosine squared theta, I can see, is equal to 1 minus sine squared theta. So I'm going to replace cosine squared theta with 1 minus sine squared theta. So that gives me sine squared theta minus sine theta equals 1 minus sine squared theta. And now I want everything set equal to 0, right? Now I'm solving this like a regular quadratic. So like, what if I had x squared minus x equals 1 minus x squared, right? I'd say get everything over to one side, right? Put it in standard form, right, to kind of see what you have. Adding sine squared theta to both sides would give me 2 sine squared theta. And then minus sine theta gets to stay. Subtracting that 1 over minus 1 equals 0. Okay, I'm going to factor this. Actually works out to the same factoring as the one above. 2 sine theta plus 1 sine theta minus 1. You can check it in the same way. So now I get 2 sine theta plus 1 equals 0. So again, to solve something like this, first isolate your sine theta term. That would give me 2 sine of theta equals negative 1. So where does sine of theta equal negative 1/2? Again, unit circle, boom, boom. That happens at 7 pi over 6 and 11 pi over 6. Solving my other one, I have sine of theta minus 1 equals 0. Where does sine of theta equal to 1 on my unit circle? That happens right at the top, which is pi over 2. Okay, so I get theta is pi over 2. And on my first one, it gives me the equations theta equals 7 pi over 6. Theta equals 11 pi. 11 pi over 6. Not 16. Too big. So if I have 11 pi over 6, that gives me these 3 answers. So my solution set looks like pi over 2, 7 pi over 6, and 11 pi over 6.